Imagine you're part of a club where everyone keeps a notebook of everything that happens in the group. Whenever somebody borrows money, makes a promise, or wins a small bet, every member writes down the details. If someone tries to change the story later, it's easy to check with the group and spot the lie. This is, in essence, how blockchain works. A club ledger, but on the internet, decentralized and cryptographically secure. So, what exactly is a blockchain? At its core, it's a digital list of records, called blocks, linked together like a chain. Each block contains a bunch of transactions, recorded, time-stamped, and bundled together. When a block is full, it gets mathematically linked to the previous one through a special code called a cryptographic hash. This hash is like a fingerprint, unique and impossible to fake without changing every block that came before it. Let's follow the process. Suppose Alice wants to send payments to Ben and Charlie. She announces her transaction to the network, basically to anyone running the right software. Rather than going through a bank, everyone in the blockchain network gets told about this transaction, and thousands of computers, let's call them nodes, race to verify it. How do they agree that Alice really has the money to spend? Each node checks the global ledger to confirm the transaction's validity. Once a bunch of new transactions are collected, they're grouped together into a block. But before this block can join the chain, someone needs to solve a tricky mathematical puzzle, a process called mining. This isn't mining like digging for gold. It's more like playing Sudoku at high speed with thousands of competitors. The first node to solve the puzzle shouts, "Eureka!" and broadcasts their solution to the network. Other nodes check the answer, and if it's correct, the new block is added to everyone's copy of the chain. As a reward, the winning node usually earns some cryptocurrency, like Bitcoin. Why the puzzle at all? It makes cheating almost impossible. If someone tried to fudge the records, they'd have to solve all those puzzles faster than everyone else, an astronomically difficult task, because every block relies on the ones before it. Faking a past transaction would require rewriting the entire history across the majority of participants' notebooks simultaneously. That's why blockchain is often called immutable. Once something's in the chain, it's nearly impossible to change. You don't need a bank or single authority to trust blockchain. The system relies on transparency and math. Anyone can join, anyone can check the math. That decentralized trust is why blockchains are so powerful, not just for cryptocurrencies, but for all sorts of records, voting, or contracts. In short, a blockchain is a transparent, permanent way to securely share and verify information. It's a digital club notebook, open for anyone to check, where the truth is protected by the computing power of the entire network.